you're having a little challenge with Rolle's theorem or mean value theorem, you're going to love these slides. It's going to help you. This video is going to be great. So for Rolle's theorem, all you have to do is two things. Show what the slope is, f of b minus f of a over b minus a. For Rolle's theorem, what does the slope between the points have to be? 0. And it needs to be differentiable on, I think they called it AB, not including A and B. If you have a slope of 0 and it's differentiable from AB, then there exists C such that f prime of C equals 0 in this case. Do you remember what mean value theorem was? Same thing, except this is M, a different slope other than 0, and this is equal to 0. Everything else is the same for mean value theorem. And we'll get to those too, but let's do this one first. Okay, so let's check, see what f of b is, or I shouldn't say f of b, let's say f of 5. And what's the absolute value of 5 minus 5? 0. 0. F of negative 5, what's the absolute value of negative 5 minus 5? 0. 0. So is 0 minus 0 over 5 minus negative 5 equal to 0? Mm-hmm. And is it differentiable on negative 5 to 5? Yeah, unfortunately, it's not. Here's negative 5, here's 5. And if you put a 0 here, a 0 here, and you graph it, put a 0 here, you're going to get negative 5. This thing is continuous, yes. But is it differentiable? No. This is called a cusp. And a cusp is a place where the derivative on the left is different than the derivative of the right. Negative 1 is different than 1, so this is not differentiable. Since it's not differentiable, the value C does not necessarily exist. It could, but we've proven that it doesn't have to. In this one, it doesn't. Sydney.
Do you go over how to tell it's differentiable, like if you don't know what the graph looks like?
Sure. The way you check for differentiability is check for like 1 over x plus 1 can't be equal to negative 1. That would be a, what is it, a infinite discontinuity. Another is if you had a square root, you can't take the square root of a negative. Whatever will make this negative won't be continuous. But it may not be in the interval, so that's okay. But the other is anything that has absolute value or piecewise has a shot at being a cusp. Pretty hard without a graph. Yeah, I would. Should we do C, the next one? All right. So we're going to look at f of 7, f of 1/2, and tell me, is this going to work for Rolle's theorem? What's f of 7? 2 minus 1/8. So that's, what is that, 15/8? All right, and then put in a half. 1, is that a negative 1/2? Yeah. So negative 1/2 plus 1 is 1/2. 1 over a half. 2 minus 1 over a half. 2 minus 2 is 0. So will this f of 7 minus f of negative half over 7 minus negative 1/2, is that equal to 0? No. So not Rolle's theorem. I don't care about that as much. What I do care about is that it could be mean value theorem if it's differentiable. So take a look at this. Where is it discontinuous? Disco at what? At x equal -1. Is -1 on that interval of -0.5 to 7? No. So we would say differentiable on -1/2 to 7 because there isn't an asymptote. And I think this problem they were looking for to see if mean value theorem worked, or with Rolle's theorem. So we don't have to do that any further.
What if it's differentiable but not continuous per se? Then it's
So if it's not continuous, it won't be differentiable. So you would say not continuous, game off for differentiable. Game over for differentiable. Yes. If it's differentiable, then you're assuming it's continuous. Yep.
Is that formula for Rolle's theorem to be accurate? Or do you have
I can give it to you. It's slope. F of B minus F of A over B minus A. That's just slope. For Rolle's theorem, what's the slope equal to? 0. For mean value theorem, it's just M. So since we did that, let's move to one where we do have mean value theorem. Let's do 3A and B. So here is f of x equals x cubed from -2 to 2. Check out f of -2, check f of 2, find the slope. Figure out differentiability and see if you can find the value. This is where it gets good.